A ceiling is an overhead interior surface that forms the top of a room, typically parallel to the floor. A roof is the outermost covering of a building, usually consisting of layers of waterproof material supported by a frame, which protects the interior from the elements. Now let's look at the code requirements. Firstly, ceilings. With respect to building codes, refer to International Residential Code, or IRC, or International Building Code, or IC, Section R601 or Section 1201. Fire resistance is specified by local building codes depending on the building occupancy and type of construction. Structural support must be securely attached to the framing system. The electrical components may require fire-resistant boxes or covers for electrical fixtures. Acoustics. Some ceilings are designed to enhance sound absorption or reduce noise transmission. Secondly, roofs. With respect to building codes, refer to IRC or IBC Section R901 or Section 1501. Weather resistance must provide effective protection against rain, wind, and snow. Structural integrity must withstand the anticipated live and dead loads. Fire resistance is specified by local building codes. Ventilation may require proper ventilation to prevent condensation and moisture damage. Energy efficiency. Some roofs are designed with thermal insulation or reflective coatings to improve energy efficiency. The key differences are that ceilings are located inside the building, while roofs are on the exterior. Ceilings primarily serve aesthetic and acoustic purposes, while roofs protect the building from the elements. Ceilings have different code requirements than roofs, with a focus on fire resistance and structural support. Ceilings can be made from a variety of materials such as drywall, plaster, or acoustic tiles. Roofs typically consist of framing, sheathing, underlayment, and various roofing materials. When it comes to structural support for ceilings, one must consider the weight of the ceiling materials themselves, including any fixtures like lighting or HVAC vents that are attached. The framing system, typically consisting of joists or trusses, must be adequately sized and spaced to support this dead load. Building codes often specify minimum load requirements and deflection limits to ensure the ceiling remains stable and doesn't sag over time. Furthermore, the attachment method of the ceiling to the framing is crucial. This may involve screws, nails, or adhesives, and the choice depends on the materials used and the anticipated loads. Proper insulation is essential to prevent the ceiling from detaching or collapsing. Fire resistance in ceilings is particularly important in multi-story buildings or in areas where fire separation is required. Fire-rated ceilings are designed to slow the spread of fire and provide valuable time for occupants to escape. These ceilings typically incorporate fire-resistant materials like gypsum board or mineral wool and are constructed to prevent flames and hot gases from penetrating into the space above. Building codes specify the required fire resistance rating, often expressed in IOs, based on the occupancy and construction type. Electrical components within or above the ceiling also pose a fire risk. Electrical boxes and wiring must be installed in accordance with electrical codes to prevent overheating and short circuits. Fire-resistant boxes and covers are often required to contain any potential fires and prevent them from spreading to the surrounding ceiling structure. Regarding acoustic considerations, ceilings play a significant role in controlling sound within a room. Hard, reflective surfaces can cause echoes and reverberation, making it difficult to hear and understand speech. Acoustic ceilings, on the other hand, are designed to absorb sound energy, reducing noise levels and improving clarity. These ceilings may incorporate materials like acoustic tiles, panels, or sprays that have a high sound absorption coefficient. The design of acoustic ceilings often involves careful consideration of the room's geometry, the intended use of the space, and the desired acoustic properties. Now, focusing on roofs, weather resistance is a primary concern. Roofs are constantly exposed to the elements, including rain, wind, snow, and sunlight. The roofing materials must be able to withstand these conditions without leaking, deteriorating, or becoming damaged. Various roofing materials are available, each with its own strengths and weaknesses. Asphalt shingles are a common and relatively inexpensive option, but they may not be as durable as other materials. Metal roofing is more durable and can last for many years, but it can also be more expensive. Tile roofing is another durable option that is often used in warmer climates. The choice of roofing material depends on factors like cost, climate, aesthetics, and desired lifespan. Underlayment is a critical component of a weather-resistant roof. It is a layer of waterproof material that is installed between the sheathing and the roofing material. Underlayment provides an additional barrier against water penetration and helps to protect the sheathing from moisture damage. Proper installation of the underlayment is essential to ensure its effectiveness. Structural integrity is another critical aspect of roof design. The roof must be able to withstand the weight of the roofing materials, as well as any additional loads from snow, wind, or even people walking on the roof. The framing system, typically consisting of rafters or trusses, must be adequately sized and spaced to support these loads. Building codes specify minimum load requirements and deflection limits for roofs. The connection between the roof and the walls of the building is also crucial. The roof must be securely attached to the walls to prevent it from being lifted off by wind. This is typically achieved through the use of hurricane straps or other specialized connectors. Fire resistance in roofs is important for protecting the building from external fires such as those caused by wildfires on neighboring buildings. Fire-rated roofing materials are designed to resist ignition and slow the spread of fire. These materials may include special types of shingles, tiles, or metal roofing. Building codes specify the required fire resistance rating for roof space and the occupancy and location of the building. Ventilation is essential for preventing condensation and moisture damage in roofs. Moisture can accumulate in the attic space due to leaks, humidity, or condensation. This moisture can damage the sheathing, insulation, and other building materials, leading to rot, mold, and structural problems. Proper ventilation allows moisture to escape from the attic space, keeping it dry and preventing damage. Ventilation can be achieved through the use of soffit vents, ridge vents, or gable vents. Energy efficiency is an increasingly important consideration in roof design. Roofs can absorb a significant amount of heat from the sun, which can increase cooling costs in the summer. Energy-efficient roofs are designed to reflect sunlight and reduce heat gain. This can be achieved through the use of reflective roofing materials, such as white or light-colored shingles or metal roofing. Thermal insulation is another important component of energy-efficient roofs. Insulation helps to reduce heat transfer through the roof, keeping the building cooler in the summer and warmer in the winter. Building codes specify minimum insulation requirements for roofs based on the climate zone. Now let's expand a little bit on the different types of ceilings. There are suspended ceilings, also known as drop ceilings, which are popular in commercial buildings and basements. They consist of a grid of metal framing suspended from the structural ceiling above, with lightweight tiles or panels placed within the grid. This allows for easy access to utilities and services located above the ceiling. Another one is drywall ceilings, which are the most common type of ceiling in residential construction. They consist of gypsum board panels attached to the framing with screws or nails. The seams between the panels are then taped and mudded to create a smooth, seamless surface. Plaster ceilings are similar to drywall ceilings, but instead of gypsum board, they use a plaster mixture applied to a lath base. Plaster ceilings can create a more texture or decorative finish than drywall ceilings. Another one is wood ceilings, which can add warmth and character to a room. It can be made from solid wood planks, tongue and groove boards, or engineered wood panels. Wood ceilings are often used in rustic or contemporary designs. Another type of ceiling is metal ceilings that are durable and fire resistant. They can be made from steel, aluminum, or copper and are often used in commercial or industrial settings. Another ceiling is a tile ceiling, which can be made from a variety of materials, including ceramic, porcelain, or glass. Tile ceilings are often used in bathrooms or kitchens due to their moisture resistance. Acoustical ceilings are designed to absorb sound and reduce noise levels. They are often used in classrooms, offices, or home theaters. Now let's explore different roof types. Gable roofs are one of the most common roof types. They have two sloping sides that meet at a ridge, forming a triangular shape. Gable roofs are simple to construct and provide good drainage. Hip roofs have four sloping sides that meet at a ridge. Hip roofs are more complex to construct than gable roofs, but they are more resistant to wind damage. Flat roofs are common in commercial buildings. They have a slight slope to allow for drainage. Flat roofs are typically covered with a waterproof membrane. Shed roofs have a single sloping side. Shed roofs are often used for additions or outbuildings. Gambrel roofs have two slopes on each side, with the lower slope being steeper than the upper slope. Gambrel roofs provide more attic space than gable roofs. Mansard roofs are similar to gambrel roofs, but they have a steeper lower slope and a flatter upper slope. Mansard roofs are often used in French-style architecture. Butterfly roofs have two sloping sides that meet in the middle, forming a V shape. Butterfly roofs are often used in modern architecture and can provide good natural lighting. Green roofs are covered with vegetation. Green roofs can help to reduce stormwater runoff, improve air quality, and provide insulation. When selecting roofing materials, consider the climate, the style of the building, and the budget. Some common roofing materials include asphalt shingles, metal roofing, tile roofing, wood shakes, and slate roofing. Asphalt shingles are the most common type of roofing material. They are relatively inexpensive and easy to install. Metal roofing is durable and long-lasting. It is also fire-resistant and energy-efficient. Tile roofing is a durable and attractive option. It is often used in warmer climates. Wood shakes are a natural and rustic option. They require more maintenance than other roofing materials. Slate roofing is a durable and long-lasting option. It is also one of the most expensive roofing materials. Roofs play a vital role in protecting buildings from the elements, while ceilings contribute to aesthetics, acoustics, and fire safety within the interior space.